Alright, so let's look at this first example. The total score in a professional basketball game is the sum of the scores of the two teams. An expert commentator claims that the average total score for NBA games is 202.5. A fan suspects that this is an overstatement and that the actual average is less than 202.5. He selects a random sample of 85 games and obtains a mean total score of 199.2 with standard deviation 19.63. We want to determine at the 5% level of significance whether there is sufficient evidence in the sample to reject the expert commentator's claim. All right, so let's start by making our null hypothesis. And I'm just going to call it HO rather than H sub 0 just because it's easier to type in. Okay, now our null hypothesis is always what the status quo is. And the status quo right now is what the expert commentator claims the average to be. So we're going to have mu. And rather than finding my symbol, which takes a little while, I'm just going to type mu for mu, is equal to 202.5. There's our null hypothesis. Now, this fan suspects that the actual average is less than that. So our alternate hypothesis, which I will call HA, is that our mean mu is less than 202.5. All right, now this is a one-tailed hypothesis test because our alternate hypothesis is a less than symbol. Anytime it's less than or greater than, it's one-tailed. If we had mu is not equal to 202.5, that's a two-tailed test. So this one is one-tailed. We need to keep that in mind when we go to look up our value for z later on. Okay, but right now, let's identify everything that we have. We have that there are 85 in our sample, and x bar, again, I'm just typing it rather than looking it up and getting it because it takes a little longer to do that. Our sample mean is 199.2, and our standard deviation is 19.63. And we want a significance level of 5%, so alpha is equal to 0.05. Okay, now, since we have a size of 85 for our sample, we can use z as our test statistic. All right, so let's set up our z-score. We're going to have 199.2 is our x bar minus our 202.5 that we get from our null hypothesis, and then divided by the standard deviation of 19.63 divided by the square root of our sample size, 85. All right, so now if I do those calculations, 199.2 minus 202.5 gives me negative 3.3 on top. And then if I take 19.63 and divide it by the square root of 85, that's going to give me 2.129172 on the bottom. And finally, if I go ahead and do that division, negative 3.3 divided by the 2.129, I get negative 1.55. All right, now we need to look this up on our standard normal chart. If we look negative 1.55 on our standard normal chart, and let me pull it up here in the background, negative 1.55 is 0.0606. All right, so the area to the left of negative 1.55 is 0.0606. This is our p-value. Now recognize that the table always gives us the value to the left, or the probability that something is less than negative 1.55. All right, it's important to remember that. Because our alternate here is asking for less, we're okay in just reporting this p-value. We'll see that there will be other things we have to do if our alternate is greater than or not equal to. All right, so our p-value is 0.006. We compare that to the level of significance, to alpha. In order to be able to reject the null hypothesis, this p-value must be less than alpha. And let me just write that out for you so you can put that in your notes. To reject the null hypothesis, the p-value must be less than alpha. In this case, it's not, which means we can't reject the null hypothesis. All right, so now that we know we can't reject the null hypothesis, we must make our conclusions. And rest assured, in your test, the conclusion is the most important part of doing the hypothesis test. So you need to write that conclusion. So there is not significant evidence to conclude that the mean is less than 202.5. It appears the mean sum of the scores of NBA games is 202.5. All right.